Jet fuel costs roughly 80 cents per liter. A fully loaded Boeing 777 carries about 180,000 liters. That's $145,000 worth of fuel. And sometimes, pilots deliberately spray all of it into the atmosphere. They open valves in the wings and dump tens of thousands of liters of refined petroleum into the sky. It disperses into a fine mist behind the aircraft, evaporates, and disappears. This seems insane. It's expensive. It looks environmentally catastrophic, and it's intentional. So why do airlines do this? The answer involves structural engineering, weight limits, and a trade-off most passengers never consider. Aircraft have maximum landing weights. To understand fuel dumping, you need to understand one fundamental principle of aircraft design. An airplane can take off heavier than it can land. This isn't a mistake in engineering. It's a deliberate design decision driven by the physics of landing. During takeoff, the aircraft accelerates along a long runway. It gradually builds speed. The wings progressively generate more lift. The transition from ground to air is relatively gentle. Landing is different. During landing, the aircraft descends and contacts the runway at a specific sink rate. Even in a smooth landing, the landing gear absorbs a significant impact. The structure flexes. Loads spike momentarily throughout the airframe. The landing gear, wing attachments, and fuselage structure must handle these impact loads with adequate safety margin, and there's a limit to how much impact force they can safely absorb. The heavier the aircraft, the greater the impact force at touchdown. At some point, you exceed what the structure was certified to handle. That's your maximum landing weight. For a Boeing 777-300ER, maximum takeoff weight is around 352,000 kilograms. Maximum landing weight is about 251,000 kilograms. That's a 100,000 kilogram difference. And most of that difference is fuel. On a long-haul flight, the aircraft might take off with 150,000 kilograms of fuel. By the time it reaches its destination, much of that fuel has been burned. The aircraft arrives lighter than it departed, comfortably under maximum landing weight. But what happens if an emergency occurs right after takeoff? The aircraft is at maximum takeoff weight. It's still full of fuel, and the maximum landing weight is 100,000 kilograms lighter than that. You can't land at that weight without risking structural damage to the landing gear, wings, or fuselage. You might blow tires from the excessive load. You might collapse a gear strut. You might crack wing spars. And in an emergency, you need to land now. This is where fuel dumping becomes necessary. Fuel dumping is exactly what it sounds like. The aircraft has dedicated fuel jettison systems that can pump fuel overboard through nozzles typically located near the wingtips. The fuel exits as a fine spray, mixes with the air, and evaporates before reaching the ground at cruising altitude. A typical fuel dump rate is around 1,000 to 2,000 kilograms per minute, depending on aircraft type. To get from maximum takeoff weight to maximum landing weight on a 777, you might need to dump for 50 to 90 minutes. But here's the thing. Not every aircraft has fuel dump capability, and even those that do don't always use it. Fuel dumping systems add weight, complexity, and maintenance requirements. For shorter-range aircraft that typically don't carry fuel loads significantly exceeding their landing weight limits, the systems aren't justified. Most narrow-body aircraft, like the Boeing 737 and Airbus A320, don't have fuel dump systems. They're designed so that maximum takeoff weight is close to maximum landing weight. The difference is small enough that landing overweight, while not ideal, is an acceptable emergency option. Wide-body long-haul aircraft are different. The 777, 787, A350, and A380 all have fuel dump capability because their mission profile requires carrying fuel loads that would create dangerous overweight conditions if they needed to land immediately after takeoff. So what happens if an aircraft without fuel dump capability has an emergency while heavy? Pilots have options. Option 1 is to fly in a holding pattern and burn fuel. Fuel burn rate in cruise is significant. A 737 might burn 2,500 kilograms per hour. If you have time, and if your emergency allows, you can circle until you've burned down to landing weight. But many emergencies don't allow time. Medical emergencies might need immediate landing. Smoke in the cockpit demands getting on the ground as fast as possible. Some engine problems are time critical. Option 2 is to land overweight. This is allowed in emergencies. Maximum landing weight is a certification limit, not an absolute structural limit. The landing gear and structure can actually handle more than the certified maximum. The certification just ensures a safety margin and limits cumulative fatigue damage. If you land overweight once in an emergency, you're not going to break the airplane. The structure was designed with margin beyond the certified limit. However, after an overweight landing, the aircraft must be inspected before returning to service. Engineers check for damage or deformation. This takes the aircraft out of revenue service, which costs money. The landing will also be harder on tires, brakes, and gear components. Brake temperatures will be higher. Stopping distance will be longer. It's manageable, but it's not ideal. Option 3, for aircraft with fuel dump, is to jettison fuel and then land at normal weight. This is usually preferred when time allows because it eliminates the structural concerns entirely. The landing is normal. The inspection requirements are reduced. The aircraft can return to service faster, but dumping fuel isn't instant. Those 50 to 90 minutes I mentioned earlier represent a significant delay. If the emergency is urgent, you might not have that time. Pilots and dispatchers make the call based on the specific situation. There's no single right answer. It depends on the nature of the emergency, the aircraft type, the current weight, the distance to suitable airports, and dozens of other factors. Let me walk through what actually happens during a fuel dump. The pilot or flight engineer activates the fuel jettison system from the cockpit. On most aircraft, there are dedicated switches and controls for this. Fuel pump pressure directs fuel from the tanks toward the jettison nozzles. These nozzles are positioned at the trailing edge of the wings, typically near the wingtips, where they're far from engines and hot components. The fuel exits as a spray. At altitude, with high airspeed, this spray is immediately broken into fine droplets. The droplets disperse in the aircraft's wake turbulence. Within seconds, they begin evaporating. By the time anything could theoretically reach the ground, the fuel has evaporated into vapor at concentrations too low to measure. Fuel dumping at cruising altitude is essentially atmospheric dispersion. Nothing liquid reaches the surface. However, fuel dumping at low altitude is different. If an aircraft had to dump fuel during approach at a few thousand feet, some fuel might reach the ground before evaporating. This is why fuel dumping is preferentially done at higher altitudes and away from populated areas when circumstances allow. Air traffic control coordinates fuel dump operations. They route the aircraft to areas where the dump won't affect other traffic. They may restrict altitudes beneath the dumping aircraft. They ensure the operation is conducted safely. You might wonder why we don't design all aircraft to land at takeoff weight. We could. The engineering exists, but it would require significantly heavier and stronger landing gear, wing attachments, and fuselage structure. That additional weight would be carried on every single flight, even flights where it's never needed. Remember, emergencies requiring landing immediately after takeoff are extremely rare. The vast majority of flights burn fuel normally and land without any weight issues. Designing for rare emergencies by adding permanent weight to every flight would increase fuel consumption across millions of normal operations. The cumulative environmental and economic cost would be enormous. The current system is a compromise. Design the structure for normal operations. Provide fuel dump capability for the unusual cases. Except that occasionally, overweight landing or fuel burn-off time will be necessary. It's engineering economy. Optimize for the common case while maintaining acceptable options for rare cases. There's one more aspect of fuel dumping that's worth understanding: the environmental impact. Dumping 100,000 liters of jet fuel sounds environmentally catastrophic, and people do raise concerns about it. The reality is more nuanced. Jet fuel, dumped at altitude, disperses and evaporates. It doesn't fall as liquid and pool on the ground. The hydrocarbons eventually break down in the atmosphere, but this takes time. However, fuel dumping is rare. Across the entire aviation industry, it happens perhaps a few hundred times per year globally. The total quantity dumped is a tiny fraction of total fuel consumed. Compare that to the alternative, carrying heavier structures on every flight, burning more fuel to lift that weight, creating more emissions during normal operations. The math suggests that occasional fuel dumping, while not ideal, results in lower total environmental impact than the alternative design approach. That said, the industry is working on solutions. Next-generation aircraft are being designed with reduced differences between takeoff and landing weights. Some newer aircraft have eliminated or minimized the fuel dump requirement through structural improvements. The long-term trend is toward eliminating fuel dumping entirely, but for current wide-body fleets, it remains a necessary capability. So to summarize, aircraft can take off heavier than they can land because landing creates higher structural loads than takeoff. Fuel dumping allows heavy aircraft to reduce weight quickly in emergencies. Not all aircraft have this capability, but those that do use it when time allows and the emergency warrants it. That fuel spray you might see behind an aircraft isn't waste. It's a calculated trade-off. The cost of losing that fuel is far less than the cost of landing with structural damage, or worse. It looks dramatic, it looks wasteful, but it's engineering making the best of a difficult situation. The next time you hear about a flight dumping fuel, you'll understand that's not carelessness. That's preparation meeting reality. There's actually another emergency procedure that seems counterintuitive. Why aircraft sometimes circle for hours before attempting to land, even when the runway is right there. It's related to fuel, but the reasoning is completely different. I've covered that in another video.